chemical equations. What's the big deal? Well, it's a mathematical way of representing what's going on in the lab. And this little picture is kind of neat, except there's something wrong about it, right? The guy lets one go, but you can't smell methane. Yeah, methane is flammable, but you can't smell it, right? Here we go. It shouldn't really be that. It should be this stuff. Those sulfur compounds are really stink, right? So it's nice to be able to, and it doesn't look like a math equation, but there's math behind it. Pretty much ratios is all we're really interested in. The ratios that things react and are produced. So in general, our reactants are always on the left-hand side and products are always on the left. That's just how we do it. Little arrow in between. Any little special conditions go on top or bottom, okay? Like sitting there in your stomach and fermenting. All these undigested bean skins. So balancing chemical equations. This is what we're going to work on today. And I don't know, later in the semester, there will be a method to the madness. What I mean is we'll actually have some rules to follow. What we're doing today is just randomly, seems to me, just working with stuff until it gets balanced, the same number of elements on both sides. But there is a few tricks, but here's a chemical equation. We've got reactants and we've got products. The question is it balanced? And what you're supposed to see is that the black spheres are carbon atoms. I think blue was there it is down here. Black is carbon, red is oxygen, blue is hydrogen. Okay. I don't know if you can see it, but there's the little blue right back there. So does it look balanced, Alyssa? Does this chemical reaction, even though it's written in terms of molecular models, does it look balanced? Right. There's how many carbon atoms on each side? 1. All right, that checks out. Stephen, how many red is oxygen? How many oxygen atoms on each side? 4. Yeah, that works. And then hydrogen, everybody? 4, right? And it's just hard to see that one back here, but yeah, there's 4. So it's nice and balanced. But we're not going to be drawing pictures, Mia. We're actually going to write out this stuff. So how would you write out this reaction? Right? For example, the black is C, and there's only one of them. But it has how many H's? 4. And then, Paul, how would I finish the reactants here? Plus what? Right, the red is supposed to be oxygen. 2. And a little subscript needs to be not 4, look, because he only has 2 there. 2. You're right, there's 4 total. Right? That's how you're going to get the 4 oxygens. There's actually 2 of these. There's actually 2 of these O2 molecules, right? There's 2 of them. 1 there and 1 there. But each molecule only has 2 oxygens. So a little subscript means a 2. Okay. Product side, Giselle, how would you write the products? C1. Red is, I think red is oxygen. So how many? Whoa. Just with this one is what you're trying to write, right? just 2. Okay. Do you see that, Lauren? Lauren, you see that? CO2 makes sense? Tanya, plus what?
Oxygen, 2.
2 of what?
Oxygen.
Okay, now. The red is oxygen, is 1. Okay.
H2.
And H2. All right. Now, there's probably a more familiar way to write this. Instead of O1H2, we usually write it as H2O, right? Make it look like water. And then a lot of times they don't like to write the 1s, right? So let's just erase these, just to follow traditional convention here. You clean this guy up. Okay. So now this is what we're used to looking at, and this is what we're going to be asked, is it balanced or not? So we do the same test. So 1 carbon on each side. How many hydrogens, Dylan, are on each side? 4 hydrogens here, right? You have to multiply the coefficient times the subscript. 4. Okay. And oxygens, 2 times 2 is 4, and I've got 2 plus 2, 4. So that's pretty much the game we're going to be playing. Now, if you wanted to balance this, though, this is, to me, is the trick to this whole thing, to realize I'll put it back. What numbers can you change when you're balancing this? Is it the coefficients out front, or is it the subscripts? It's the coefficients out front. Because you realize if you wanted to change these subscripts, you would actually have to break this model or add stuff to it. You're changing the whole molecule. You can't do that. So you can never, ever mess. You can't mess with the subscripts. All you can do is mess with these coefficients out front. That's how you balance. Now, there's a fancy word for those coefficients, Kendall. It starts with an S. Does anybody know? Well, let's see, I before E, except after C. I think that's how you spell it, coefficients. They're called stoichiometric. You really don't need to know that, but sometimes I think the terminology helps. It's these stoichiometric coefficients are what you adjust and can modify to get balanced equations. Okay. So this is really the only hint I can give you. We're going to be given reactions like this number 1 down here. And the homework is just balance it. Okay? And the only advice I can give you is balance last any element that occurs by itself. Because it just makes life a little bit easier. It's the only thing you can do. So in other words, in this problem right here, balance that last. Right? It's an element all by itself. You don't have to do it this way. It's just life is a tad easier if you do it this way. Okay. The homework is going to expect you to know that whenever you burn anything, Audrey, they call it a combustion reaction. Whenever you burn anything, it always produces what and what? Whenever you burn anything. Does anybody know? What do you get? So you get CO2 and H2O. Good. Connor, good job. CO2 and H2O. They expect you to know that. So you'll see why in the homework. Okay. So we'll do this first one together, and then we'll go to the boards and see. We'll try to make this as painless as possible here. Okay. So let's pick on Emily. Emily, what element would you like to balance first? Sodium? Okay, she had to pick sodium. Okay. Well, I've got how many sodiums on the reactant side? Ashley, how many sodiums do I have on the reactant side? 2. How many on the product side, everybody? 3. So what could I do here? She picked an ugly one to start with, but that's okay, right? 2 over here, 3 over there. So what could I do? You could just start with another element, but we're going to stick with it, right? Okay, what did you say, Megan?
Make the one on the left side 4.
Make this a,
No, on
oh, left, make that a 4. So I mean, you're saying put a 2 out here? Okay. And then what?
Put a 2 in front of on the reactant side, the first one.
Okay. That works, right? Because then I've got 2 times 2 is 4, and 2 is 4. Okay. Lorena. So sodium is balanced. Let's balance another element. What would you like to balance next? S. Good. She didn't pick I. So how many sulfurs, Sydney, do I have on the reactant side? How many? 4. Yeah, you got to multiply the coefficient times the subscript. So I've got 4 sulfurs on the reactant side. But Bowdy, how many sulfurs do I have on the product side? 4. Ooh, maybe Emily had to start out at the right spot, huh? All right. Megan, what would you like to try balancing next? Oxygen. Good. Leave iodine last. So, Kenneth, how many oxygens do I have on the reactant side? 6. Yeah, sorry. Kenneth's way back there. 6. Product side, Stephanie? 6. 1 times 6. All right, so that's done. Connor, what's left? I think the only element we haven't done is I. So iodine's on the reactant side. 2. Whoop. 1 times 2. Right, so 2. Product side, everybody? 2. 2 times 1. So it's done. Woohoo. Okay, so you know the name of the game. So we'll do these together. We'll go up to the board and we'll do these together. And then we'll do a bunch of naming together. Okay? So again, if you see an element on its own, balance it last. Yeah, there you go. Yep.
Okay, because I was doing this before we got on the board. So, like, is there a specific way this has to be? Like, is it supposed to be as small as it needs to be, or just?
Yeah, well, you want to look at it so that it's simplified. So you can't divide through, but like if they all had a common factor of 6,
Oh.
then you divide through by 6.
Okay, none of them have a common factor.
No. Yes, you're fine.
It's like, you know, Friday when I went to the chemistry club. So you
Uh-huh.
sell the chemistry shirts because I needed to check if they were still in, like, in my sizes.
Yeah, we might. We just check with me after class. So try to leave O for last.
Whatever you do with this side, do you have to do with this side, or can you just
No, because it's not balanced. You're right. If we went through all the work of having it balanced, then if we multiply something times this side, we have to do it to that side. Yeah, that's
Okay,
that's
so-
getting ahead of where we're at.
Okay.
So yes, 6 C's, so you put a 6 C's. Good, then keep going. Good. So if you're not sure where to start, I don't know, I think like the carbons might be easy. So just put a 6 in front of that. That might be a good starting spot. Oh. Okay, there's a little trick to doing this. I can show you another trick. Let's say you did do the 6 C's. Did anybody figure this out first? You got the 6 C's. All right, they're done. 6 hydrogens, so you put a what in front of the water? A 3. Okay, now okay, oxygen's all by itself. Smith said leave oxygen last, right? Here's the advantage of it. Okay, how many oxygens do I have on this side? 15, right? So it sucks. It's an odd number. So you want how many oxygens on the reactant side? 15. So you do that, but you kind of cheat. 15 all over 2. Right? You can do that. Because 15 over 2 times 2 is 15. It's balanced. So for the rest of the semester, man, this will give you the right ratios. Except that we want to write balanced chemical equations. So Kenneth or somebody was asking, there are a few little rules. One is if you want to follow conventional ways of writing chemical equations, do they like fractions? No. So we'll just multiply everything through by 2, right? Because I think Lauren asked, if I do something to one side, don't I have to do it to the other? Yes, but only after it's balanced. We've got a balanced chemical equation. So now, if we do something to one side, we have to do it to the other. So the last step would be multiply both sides through by 2. So if I do that, I'd end up with, here's my reactions. C6H6 plus O2 CO2 plus H2O. So I have to multiply everything through by 2. So I ended up with how many C6H6s? 2 of them. And how many oxygens? 15. And how many CO2s? 12. Megan knows. How many else? How many waters, everybody? 6. And that's the best answer you can give. Then I guess before you move on, you should look and make sure that there's no common. You can't divide through by. I don't know. Sometimes you can divide through by 2 or 3. There's a common factor, but not here. There isn't. Okay. 15 has to be the stoichiometric coefficient has to be a 15 in front of the O2 chemical formula. But 15 times 2 is 30. So there's 30 oxygens on this side, and then count on the product side. I've got, here I have 24 oxygens, and here I have 6 oxygens. So 24 and 6 is 30. So it works. Now, in 3, there's no element sitting there by itself, but I would leave see if you can leave the ugly ones for last. For example, like, look at hydrogen showing up all over the place. So I probably wouldn't do it first. Do something like P or O or something first. So help each other out if you got 3. See if the folks around you got number 3. Let's get it. 4 times 2 is 8 hydrogens. 5 and 3 is 8 hydrogens. It looks like it works, right?
Yeah, that's why I'm writing above.
So did you get number 3? In number 3, the P's are done. How about the chlorines? 5 here, so I'll put a 5 here. There's got to be more than one way to skin this cat, but 5 chlorines now on both sides. Now I might as well do the hydrogens. 5 hydrogens and 3 hydrogens. I've got 8 hydrogens on this side. So I need 8 hydrogens over here. Put a 4 there. 4 times 2 is 8. Now I have 4. Hey, 4 oxygens on both sides. It's done. Okay. Where did I lose you?
Oh no, I'm trying to figure out where you got the 8, but I got it.
Okay.
5 times 1.
Yeah, and adding on to the 3. When you're working on 4, make sure you can understand this, those parentheses, right? There's a little 2 subscript outside the ammonium. Recognize NH4? It's ammonium. So you really have 2 nitrogens and 8 hydrogens with ammonium sulfate, because you really have 2 ammoniums. That's what the little 2 down there for the subscript means for ammonium.
Why did you?
So you've missed several classes, right?
Yes, sir. Actually, I had to talk to you about that.
Yeah. Talk to me after class, and then we'll catch up.
So what have we already done? Where there's 10
Could you multiply just the nitrogen by 2?
Yes. You have 2 N's and 8 H's there. Anybody get number 4? Yeah? How'd you do it? You put a 2 in front of the NaOH. So I've got 2 sodiums, Let's check something ugly like the H's or the O's. Here you've got 4 O's and 2 is 6 O's total. Yeah, 6 O's. I bet you this is right. 6 H's, 2. Uh-oh. What happened here? Oh, I forgot these two. 2 times 2 is 4, and 6, I've got 10 total. So here I've got 2 plus 8, 10 hydrogens. It works. So we need a 2 in front of the NaOH. I'm going to copy yours. Stephen got it in the back there. He's got a 2 in front of the NaOH, 2 in front of the ammonia, and a 2 in front of the water. All right. So let's make sure that this works. All right. Here I have the nitrogens. On this side I've got 2, and the nitrogens over here I've got 2. So you see that? 2 N's and 2 N's. All right. The hydrogens, I've got 2 times 4 is 8, plus 2 more gives me 10. Can you count that? I've got 10 hydrogens on the reactant side, the way Stephen's got it. 2 times 4 is 8, plus 2, 10. Product side, 2 times 3 is 6, and 4, 10. All right. The oxygens, 4 oxygens from the sulfate, plus 2 more would give me 6. The oxygens here, 2 plus 4 gives me 6. Okay. And the sodiums, there's 2 on each side. So make sure you can see that on number 4, how we're balancing that.
But if they wouldn't all just divide out by 2.
Oh, it looks like it, but if you didn't have these guys, you're right.
Yeah.
But you've got 1s in front of them.
Okay.
So you can't divide through by 2. You'd end up with fractions. You'd end up with a half here.
Okay.
Yeah. I think that's what Alyssa has, right? You have the same thing as she does. 3 N's. Yeah. I think it works because you've got 3 nitrogens. Make sure your nitrogens are capital N's, though. You got 2 and 1 is 3. 6, 7. Yeah, and 7 oxygens on both sides. That works. So a couple people got this last one. Did you get it? All right. And then you put a 2 way over here. Then I'll have On this side, 3 nitrogens. Whoop.
So when we finish, we just sit down.
Well, we're going to do the next part. Yeah. Put the answers and try to fill in that table. 3 nitrogens. This side, 3 nitrogens. 6, 7 oxygens. 7 oxygens. 2 hydrogens. 2 hydrogens. So if you get number 5, go on and see if you can fill in the name. Write down the names of the first 5. Write down the names of first 5. Write down what you think the names are of those. If you got number 5. If not, let me help you out if you don't quite see it. Go ahead and write down and start naming stuff. Anybody not get number 5 so I can help them out? Everybody got it? Okay.
So just wrote down what you had up there.
Yeah, okay. So somehow they figured this out. So they said, if you can verify it's the right answer, that would help.
Yeah.
So I've got 3, and there's only a 1 here. So I have 3 N's here, no N's here. So I have 3 N's total. Here I've got 2 N's and 1 more.
That's 3.
That's 3. Okay. Now how about the oxygens?
6.
6 plus
7.
1, 7.
6.
Plus 1, 7.
Maybe I missed the 3 on the bottom.
Maybe.
Because I didn't have,
Yeah.
I think I didn't have that there.
Oh, okay. Yeah, then it won't work.
And that makes sense. Okay, I think that's what I was supposed to
Okay.
do.
Good. Ammonium sulfate. So this very first one, hopefully you named it ammonium sulfate. So try to get away from using that table of polyatomic ions because you have to have it known, right? Let's just name this, see if we can name this whole first top half of this box. If we'll have time, we'll name the bottom half. Yep.
When it comes to naming the ones after number 12,
Uh-huh.
the transition numbers after number 12, so we had to put the Roman numeral.
Oh, you put the Roman numeral for all the metals, all of them, except for the ones where their charge is fixed. So that means group 1 and group 2, you don't put Roman numerals because their charge is fixed. And then there are 2 exceptions, aluminum and zinc. Aluminum was always +3, zinc was always +2. Right? So for these metals, remember the key to naming these metals is you always use Roman numerals, except when the charge is fixed. And the charge is fixed for group 1 and group 2 and aluminum and zinc. Aluminum is always +3. And zinc is always +2. And group 1 and group 2. Those are the only metals that you don't use Roman numerals. Do not use Roman numerals for metals in naming. Okay.
So,
Yep.
I spell beryllium.
B-E-R. See which one you're doing. Down here. And remember, spelling counts.
On these formulas,
And I'll change the color. It says beryllium phosphate.
on the formulas right here, if it's the Roman numeral, the subscript is added to the
Yes.
symbol.
Yes, exactly. right, are you getting these? Ammonium sulfate, aluminum sulfide, iron 3 hydroxide. Yep.
When we're doing
Yeah,
this,
keep going, name them all.
when we're doing this, are we going to have a periodic table to look at?
Yes, you'll always have the periodic table, but that's it.
Okay,
Yeah.
We can see, like,
Oh
what's
yeah,
going on.
oh yeah.
Okay.
So your periodic table is the only cheat sheet you really have on this, right? So make the most out of that cheat sheet. When you named NH3, is there a metal? No. So that means you got to count to 10 in Greek. Use those Greek prefixes with NH3. No. Yeah, that monocarbon, the mono in front of the carbon is not necessary. A lot of people drop it. Oh man. Did anybody get this sodium one? Sodium. That thiosulfate. You don't see that polyatomic ion very often. Thiosulfate. That's an ugly one. How did you name K2O? Potassium oxide. No Roman numeral because that's group 1. And then this beryllium one is beryllium phosphate. B-E-R-Y-L-L-I-U-M, phosphate, P-H-O-S-P-H-A-T-E. How about that one? Am I picking something? Chromium 3 hydroxide. Very good. Chromium 3, Roman numeral, hydroxide. See if you can finish this table out. It's going to get tense in lab. I tell you, it's. If you ever watch Family Feud, families get excited. So know those polyatomic ions. This is exactly the kind of thing we'll be doing in a game format.
If it's a game, do we win something?
You should win something, shouldn't you? Right? Yeah, I should get something. That's a good idea, Megan. Rebecca, how did you name this one? This box? Everybody, chlorine. Because the first one you don't add an IDE. Dichlorine pentaoxide or pentoxide. How about, ooh, this is a good one. Al4C3. Anybody? Lauren, what'd you get? Aluminum. Aluminum. No parentheses because aluminum and zinc are the special cases. So just aluminum, no Roman numeral. Aluminum carbide. Do you recognize it? Al has a +3. C has a -4. It's 4 away from the nobles. That's why there's a 4 down there and a 3 down there. Aluminum carbide. Which one? Oh, this one? This is tough.
Is it 3 words? Is it
That's a tough one.
hydrogen carbonate?
That's a tough one. Let's get there first. We might get there. How about, anybody get this one? Ammonium chromate. Good. Lithium acetate. Very good. Calcium. You can say calcium hydrogen carbonate or calcium bicarbonate. I think both names might be listed in that table. H2S. H2S. Dihydrogen sulfide. Potassium chlorate. You said sulfur dioxide. Lead 2 nitrite. Yeah, because nitrate has one more O. Nitrate would be the NO3. Lead 2 nitrite. And the last one we'll leave for lab. I'm pretty sure that's in lab.
Is it 3 words that you use? Is it calcium hydrogen carbonate?
Oh, it looked like. No, they write it all in 2 words. Yeah.
So it's hydrocarbonate?
You could call it hydrogen carbonate.
That's how it is.
Yeah. Or
Hydrocarbonate.
bicarbonate. Calcium bicarbonate. So have a good day.
Why bicarbonate?
That's just another name for it. Either one works. What's that?
The last one.
We'll do that one in lab. See if you can figure that one out.